Hello friends, in my this video I am going to discuss about reverse run length encoder. Okay, that is basically nothing but run length decoder. Okay, so in my previous video already I have discussed in detail about run length encoding in MATLAB. If you want, please go through the link given in the description, because to understand the decoding technique you must know the encoding technique, right? Because encoding first comes, then comes decoding. All right, then we are going to discuss with respect to MATLAB. So what is that? See, very simple. If you already checked my previous video, then you know that in run length encoding we basically use this for lossless data compression technique, and this compresses data when we have a long run of same integers consecutive to each other. Like here, if your run length encoded output is 251241113, then this is not our original sequence, this is our basically encoded sequence. Just pronounce this particular sequence like this: first one as frequency and second one as integer. Okay, now if you pronounce, what you will get? 2, that is TWO, 2 5s. Okay, that is 5 5. Then 1 2, that is only one, right? 2. Then 4 1, so 4 FO you are 1, so 1 is appearing 4 times, so 1 1 1 1, and 1 3, that is only one time 3 has to be taken, so 3. So our original sequence is 5 5 2 1 1 1 1 3. All right, like you take the example 1 9, that is only one time 9 is appearing, so output is 9. You take this particular sequence 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8 1 9. What this indicates? Only one time 1 is appearing, only one time 2 is appearing, only one time 3 is appearing, only one time 4 is appearing, and so on. So 1 to 9, only one time all the characters or all the integers are appearing, so output is nothing but 1 is to 9. Okay, so that's what we have to do in programming, that we have to input this particular sequence which will give this as output. So what is the algorithm? That's what you have to understand. So see, step by step we will go. Step 1 is nothing but, obviously we have to take input from the user, the run length encoded signal or sequence. All right, so take input from the user, CLC clear all close all. If you want, you can write warning off also. Then x equal to input, enter the array. Okay, then see, step 2 is frequency extraction. What is that? See, as I have shown you in example, this particular input sequence 251241113 is nothing but 552111113. That is, this particular first term 2 is nothing but showing the frequency of 5. This 1 is showing the frequency of 2. This 4 is showing frequency of 1, and this 1 is showing the frequency of 3. So we have to extract the frequency. So what we can do, we can take one for loop for I equal to 1 colon 2 colon length of x. So we are starting our for loop from the index position 1 in the input, and we are taking our loop up to end with incrementation of 2. Why? See, this is frequency of 5, that is 2. Then after incrementation of 2 you will get this index where this 1 is there and 1 is showing the frequency of 2, right? So basically frequencies are arising with incrementation of 2. So here for I equal to 1 to 2 to length of x, yx of I, that is basically it is storing the frequencies of each integers. And here see, this y we are defining as empty array to store the frequencies. Okay, then after that what we will extract? Obviously we will extract the digits of the integers which are repeating in our sequence. There is 5 2 1 and 3 which are basically repeating. So that what we can do, that is extraction of numbers. So what we will do, we will define another array z, and we will start our index from 2, because this particular 2 which is corresponding to index position 1 is basically nothing but frequency. So if you want to extract the digits or the original integers which are basically repeating in our main sequence, we have to start index from 2. So for I equal to 2 with incrementation of 2, again same reason, to length of x, z equal to z x of I, and define z as one empty array to store the numbers which are basically repeating and making our original sequence. Then what we will do, see, we already got the frequency, we already got the numbers. So just what you have to do, we have to repeat the numbers according to the frequency, and we have to store those in an empty array, new empty array, and we can get our original sequence. So see, frequency wise repetition. So for I equal to 1 colon length of y is basically, see, our frequency array is y array. then m equal to y of I, q equal to z of I. Just we are extracting one frequency and corresponding integer, and we are repeating those m times. M is, that is frequency time. For j equal to 1 to m, v equal to vq. What is v? V we have to define before this particular for loop as one empty array. V equal to one empty array in this for loop, in this outer for loop. Okay, that's all. See, let me simulate this. See, CLC clear all, close all, x equal to input, enter the array. We are defining one empty array for storing the frequency. Then we are extracting the frequencies, and see here what, yeah. Then Z1 empty array we are defining for storing the numbers. Then here V1 empty array we are taking for showing the output, and we are repeating our numbers according to the frequency. Okay, that's all. So here V will be equal to nothing but V, and then what? Here we have to write Q, right? See here, already I have shown you V equal to VQ. Okay, let us check. So suppose, sorry, let me do evaluate selection, enter the array. Suppose let me write 1 9. So 9 is appearing only one times. If you write V and enter, see 9 we are getting. Okay, so our reverse run length encoder, or basically run length decoder, is perfectly working. Let us check with some other input also. So take this particular sequence, Control C, and here you just paste it, Control V, and here, sorry, I forgot to give this space. So sorry, CLC, Control C. Let me do again. So Control A, evaluate selection, enter the array, paste. Okay, I forgot to give the brackets. You must have to give the brackets when you are giving array as input. See what you are getting as output for this particular sequence. Write V and enter. See 2 5. 5 is appearing 2 times. See 5 is appearing 2 times. Then 1 2. So basically 2 is appearing only once. Then 4 1. So 1 is appearing 4 times. Then 1 3. So 3 is appearing only once. Okay, so our run length decoder is perfectly working. Okay, so try to understand the algorithm, because if you are able to understand the algorithm, you can implement same concept in Java or C or C++ or Python, whatever your favorable language is. Okay, this is all for my this video. I'll post the same code in the description. If you want, you can have a look there. Okay, thank you for watching.